Yeah.
I don't play off. I don't get fast. All these people. Oh my. I don't play.
Wanted the fulcruments to block. I just want to show you some of the ways I've done it. Where I want to place the fulcruments, according to how I'm going to move the block, what I'm going to use. This block here, I'm just going to place 2 fulcruments, and I found some nice stones that'll fit right in there. Chip some holes in the block, and want a little bit of a flat spot. That one will work good, right, just like that. And that one looks like it fit in there just fine. I left my center lines on there, so I should be able to line these rocks up right where I want them. I want to keep them fairly even. If I can get a flat spot, that's good. I like that. There you go. Just gave my block some feet in order to walk. Okay, I'm going to show you this other one over here. This is the second way I came up with. I just drill the holes where I want the fulcruments, and I'd use a bolt, a rag, and just drive it in there. Okay, here's another method I came up with. You just drill a hole and insert this into the hole, put a little grease on it. The grease helps hold it in actually, and it creates a little suction in there. And then you actually, the whole fulcrament spins. This way here, I'm not damaging the concrete. Or of course the other way too. I showed you that board where I put the fulcruments right on the board. This is pretty neat because I don't have to roll the block over. I tested that for about 3,000 pounds. And now I'd like to show you a demonstration of my Egyptian hoist. I call it my Egyptian hoist, or that's what I refer to it as, because I use the 2 angles of the Great Pyramid. The interior angle is 26-degree angle. It's just a simple 1 unit of rise and 2 units of run. The other angle is the outside angle I use from a ramp to hoist the blocks on. It's just a simple 3, 4, 5. It's close to 52 degrees. The 3 units of run, 4 units of rise, and the diagonal is 5 units. You also notice too a simple roller I placed to the top. This to redirect power. This 100 pound weight that I found I could hoist alone at the speed of 10 vertical feet in 6 seconds. This creates over half a horsepower. The other weight I'm working with here in my demonstration is this 505 pound block. I made this up to demonstrate what 3 men could do on the hoist, and I also included some fulcruments on it so I could move it around. The block weighs 505 pounds, and I found out that 3 of us could hoist at 10 vertical feet in 4 seconds. Yes, creating about 2 1/4 horsepower. 30 men, instead of 3, could hoist over a 5,000 pound block at this speed. We're getting ready to pour my next block. The dimensions of the block are 2 foot deep, 4 feet across, 16 foot 8.5 inches. I believe the block weighs in the neighborhood of 20,500 pounds. I have calculated the concrete to weigh 20,050 pounds. The 600 pounds of re-steel, displacing 1 cubic foot of concrete, which brings it up to 20,500. Something I neglected to show you on the first block was going to the re-steel. Also, I'm showing you here the anchors I pour into the concrete to hold the center board. Most importantly, that's a safety item, I believe. If the center board isn't securely in place, it'd be difficult to tip the block on end. I don't plan to experiment with safety, so I'm use some good solid anchors. Also, I anchored the some anchor bolts for the fulcruments, which don't necessarily need to be strong, but I made the anchors out of some nuts, pipe, a couple plates, a couple pieces of re-steel, welded them together. Anyhow, we're ready to pour the block. Okay, here's young Jimmy. He's helping with a strike off the block. There's Brendan over there. I wanted to show you a little bit about laying out that round road. Okay, here's the block, the size of the block that I want to use on that road. In order to lay it out, I'm not going to use any rulers or numbers or anything. First of all, I got to find the center of my block. I'm just going to take a stick here and find the center. By going corner to corner without using a measurement, I can intersect the corners, give me the center of the other line, which will give me the center of the block. Okay, now I want to get the width of the block, mark it on my stick here. Now I want to establish the center of the stick. The intersection point there. Alright. Now I have this is a point here. the center. Now if I wanted to roll this block around, I could make it round. One way to be to strike on it here and shave off this part of the block. The block would be round, so it would roll. What I got to do, since I want to keep the block square, I have to take this dimension of the block and place it over here to make it the same size. So if you can get the point, I would make this block round by adding this amount in the center. So I got to mark that amount. So I got the three things I need. I have the difference, I have the center, and I have the width of the block. That's all I need to lay out that road. Okay, stepping over here to a piece of plywood I can lay out my pattern with. First thing I have to do is establish a working line, which could be pretty simple to do. Something like this. Just parallel the edge of the board. That's how I test the material road out of. Now I have to establish the center. See this? Yep, this is. Okay, establish the center. And up here. Now I'm going to mark down the distance between the horizontal diameter and the vertical diameter. Put a nail there to hold my stick since I don't have any help there. Now I put the. Okay, went in and found the stick's a little more flexible. I'm going to transfer the marks over to it. In there. Now the center of the block is on the nail there, and I want to bring these 2 points back to the line. But if they don't have 3 hands, I have to put another nail in. Okay, put that on the mark. Edge of the block on the center, very close. We'll work it around in there. There's my layout for my road right there. The arc of the road. Now I'm going to add this piece onto that block when I roll it, and there's the length, the diameter of the block, which will be rolling on the road. And I raise the block that much so the center line of my block doesn't go up or down. So in order to roll the block over the road, I don't have to lift it. Another thing I can show you here, there's little proportional measurements. A little proportional work. Let's say I want to make a square point here, and let's say a 52-degree angle on there. Oh, let's take my pencil. This would be a good dimension here. Yep. All right. I'm just going to mark out 5 segments of my pencil on this board. 2, 3, 4. Alright, look at that come out right in that mark there. How about that? Look, there's an extra one there. Okay, I'm just going to lay out a 3, 4, 5 here for you. Starting point. Going out 3 segments. 1, 2, 3. A vertical. I'll take 4 segments. 1, 2, 3, 4. A little arc there. Now, 5 segments from this. I'm going to intersect that line. Now this gives me a 90-degree angle. It's just typical 3-4-5, just showing you how I do it, in case you don't know. Three segments, 4 segments, 5 segments. This angle here, 90 degrees. This angle over here, 52 degrees, which is really close to the outside angle of the pyramid. Which in fact, I think it was the angle of the pyramid. Now, move the camera a little bit here. Now I'm going to just draw, since we established a 90-degree angle, I'm going to go 2 segments and 4 segments. 1, 2, 3, 4. Now this angle, believe it or not, is the angle of the interior ramps of the pyramid, 26 degrees. That's just a 1-2 angle. 1 unit of rise, 2 units of run. I use 2 and 4, but it's the same thing, proportional measurements. So I got the inside ramp angles and the outside angle. No tape measure. Okay, I just completed my first attempt at rolling a block on the round road. That's what I showed you there. And I wanted to give you a little detail on what I did with the road. You see, this is the layout I used from the one I showed you how to make it. And then I used double plywood on each side, and I set some 2x4s in the center, recessed them a little bit, put some polyurethane on them to protect them from weather, and also put a sandy surface on it. And on the other side of the block, I got this rope. And the rope is to come in contact with the sand and keep it from slipping on the road. My first road was round, just like this, or elliptical shaped somewhat, rather than perfectly round. And what happened when I would try to use the round surface, the block would slip at the start, and then that would create problems. That's why I went with a segmented road. Now I'm going back to the original road and adding some traction here. The original design, the original road I started with seems to work real well. It's real smooth. You can see by the demonstration there. And the rope works well in keeping traction so the block doesn't slip when it's climbing the road. And also the momentum, once you get it started, you want to keep on going because the momentum really is helpful there. Also, I added some cleats to keep my block in the center of the road because I am using the block for counterweight. If it went to one side or the other, it would affect the position of the counterweight. This is going to make it easy. It took me almost 5 minutes to shift my weight before one end of the block to the other, my counterweight, and now it's just going to take me a few seconds. So this should really pick up the speed of how quickly I can move the main block here. Okay, I got a beautiful number of a day to work with here. It's been about a month since I poured the main block. I had to wait the month in order for the block to get proper curing. Okay, you notice I put my centerboard in place this time ahead of time, and I'm going to try to use the counterweight. Last time I rolled the block up, that was mostly for demonstration, but I believe this is going to be a lot easier on me this time. And since I got my counterweight in place, I can walk it back and forth, removing pressure from the ends of the form and start to remove them 2x4s down there, and I should be able to walk the block right off of my formwork. So that worked pretty good. Except I had to bust up the lumber a little bit. Once I was able to tip it enough, though, I was able to clear it out pretty good. I'm using the same fulcrum I used last time, except I've created a little bigger flat spot on it. This way I'm distributing the weight over about 3 square inches or so. So the block weighing about 25,000 pounds, I'm putting about 8,000 pound PSI on it. The concrete will take about 4,000, so it's about twice what the regular concrete would take. I'd have to go to about an inch bigger spot in order to be able to use it directly on the concrete. I got enough room now to slide this underneath and bolt it up. I'm going to, I'm only using two end beds to bolt this to this time. Well, no, I didn't need quite as much as before, but I can slide that right underneath there, put that on. It'll take the block out for a spin. Right now I got my block all ready to go. You have both fulcruments on and the counterweights are in place. When I first began this, I would do everything by trial and error. Then after a while I realized I can do it with a little bit of math involved, just simple weight and balance problems about where to put the counterweights and where to locate the fulcruments. It's kind of a balancing act, and you see the block is teetering right now. We used to move the barn around. We used to consider this at the point that it's alive. You can see all of the kind of characteristics that it's at the balance point. Anyhow, I got the fulcruments are at the same elevation as the centerboard, so everything kind of comes in contact at one time. You can see the block is rocking. I can make it rock a little more with just simple inputs. If I try to stop the block, it's just about impossible. But when I do stop it, you can still feel it appears to stop, but I can still feel it rocking. It'll do that for quite a while. Kind of like the energy is flowing back and forth in it. Momentum and that sort of thing. But anyhow, this block is ready to move right now. You see it's just the entire weight is on the one fulcrum point. Let's take a look underneath. Okay, I'll give you a little close-up here of the fulcrum point. This one does not have the weight on it. See, it easily goes up and down off the ground there. Then the centerboard, you can notice that. Let me change the angle a little bit here. Okay, notice while the block is rocking there, both points on the centerboard are clearing the ground. Means the entire weight, let me lock it a little more here. Everything, absolutely everything, is on that one point. This is what's kind of neat about this, handling this mass weight. You can stick it on a point real easy and it wants to stay there. I mean, it would take an input to knock it off at a point. You want to keep it so all four are just about the same elevation. It did help a bit for me to give it more of a flat spot down on the fulcrum down there. When I was just using a 1/2 inch flat spot, it would easily come off it. Now let me give you a look at the other fulcrum, the one the weight's on. Okay, all the weight is on this one. Let me get the block rocking a little bit. The entire weight is on that fulcrum. That means all I'll be moving is mass. I just have to overcome friction on that one point, and I can move the mass, not the weight. the weight's being taken care of here. It's June 2006. What I'm going to try to do now is to walk my block up against the vertical block. See how tightly I can get it fit by the walking technique. Notice I changed the center board, just put some spacer blocks in there, and also I added some handles on my counterweight block. This is going to make it a little easier. I don't have to climb up on the block to roll the counterweight.